This is my corrections for my Unit 3 PQPP 1 homework assignment. So this is the first problem for the homework. The question is, a certain orthodontist uses a wire brace to align a patient's crooked teeth as in the figure. The tension in the wire is adjusted to have a magnitude of 18 newtons. Find the magnitude of the net force exerted by the wire on the crooked tooth. So this is the work that I did on my paper originally. So the 14 newtons is on the wire going both ways like this. So it's 14 pulling this way. The teeth are right here. And compared to the perpendicular is at a 14-degree angle to the horizontal. And I said that the sine of each, so basically these are all the teeth. This is perpendicular. This is the wire's tension. This angle is 14. And the force of each individual string is 14 newtons. So you're trying to find what is the force that the crooked tooth is applying this way. So it is equal to 2 sine, because sine is in the sense of the y direction. So I said F wire sine of one side, sine of 14, minus the force of 2 crooked teeth is equal to each other, which is wrong. But further, 18 sine of 14 degrees is 2 force divided by, you evaluate is 4.35 divided by 2. The force of the crooked teeth is 2.17, 7 newtons. The comments on this problem was, the first one was, wrong sum of forces in X, no square root for resultant and incorrect answer. Yeah, that's correct. I did not use the square root. And then second one was incorrect corrections, which messed up all of the answers, which is also agreeable. So the correct way that I should have done this was, pull it up real quick. So E of f of x equals ma, x equals t cosine theta minus, or you put the degrees, t cosine 14 minus t cosine 14, which equals 0, because they are pulling in opposite directions, canceling each other out. In the y direction, going inwards towards the teeth, same thing, m-a-y, but this time, since the sine direction is both in the same way towards the teeth, it would be negative t sine of 14 minus t sine of 14, which equals negative 2t sine of 14. And then the magnitude of the resultant force, you would have to square root it, because you were trying to find the x and y component and then find the total tension force pushing out on the teeth. So you would do square root f of x squared plus f of y squared. That would give you the square root of negative 2t sine 14 squared. Since 0, these two would essentially cancel each other out. Then you're left with, and since it's squared, it would be 2t sine of 14, which is 2 times 18 times sine of 14. And that gives you a force of 3.71 newtons. This is the second problem that I'm doing corrections on. The question states, a 3 kilogram object undergoes an acceleration given by acceleration equals 2 I hat plus j hat meters per second squared. Find A, the resultant force acting on the object, and B, the magnitude of the resultant force. The comments on my homework says I did not state F equals ma, and the second one states the same thing as well. this is what I did. So the question says that acceleration equals 2 I hat j 5 j hat, and if it's a 3 kilogram object, mass acceleration, you times it both. This is the x and y component. You're trying to find the magnitude. You square root it. Pythagorean theorem. I get 16.15 newtons. So there was 5 points given to this. No, there was 15 points given to this. 5 was given to this area over here. 5 was given for this, but I lost 5 because I did not state F. The force equals mass times acceleration equals 3 times 2 I hat plus 5 j hat. That's why I got it wrong, or I lost 5 points. This is the third problem. The question is, if a single constant force acts on an object and moves in a straight line, the object's velocity is a linear function of time. The equation velocity equals v naught plus acceleration times time gives its velocity as a function of time, where acceleration is the constant acceleration. What if velocity is instead a linear function of position? Assume that a particular object moves through a resistive medium. Its speed decreases as described by the equation v equals v naught minus k times x, where k is a constant coefficient and x is the position of the object. Find the law describing the total force acting on the object. This is what I said. Velocity equals v initial minus k of x. Therefore, force equals k times mass times velocity. Because if the position changes, the velocity changes. So if the velocity changes, it's acceleration. If it's acceleration, if it's accelerating, that means there's a force being applied to it. And yes, I think that's my reasoning I had. I do not remember this problem that well. For the comments on this, it said I got 5 out of 15 because I used the incorrect sum of the forces and did not equal it to MA. The second one, I got 0 out of 15 because I did not show work. So the way you solve this out is velocity equals v naught minus k of x, which is equal to acceleration equals the derivative equals 0 minus the derivative of k d of v over d over t, which is then equal to negative kv. And then the total force is equal to the sum of the forces minus equals mass times acceleration equals mass times kv, which is substitution, because acceleration equals negative kv, Oh yeah. Oh, he had a typo. Yeah, he had a typo. And the force is equal to negative kmv. So that's what, I guess I got the answer, but I did not show my work. Simply put. This is it for corrections. My fourth and fifth question, I got all the points, so this will just be on the first, second, and third question.